In today's lesson, we are going to continue with the topic of composite shapes. However, we're going to look at the perimeter of composite shapes. But before we do that, we're going to look a little bit at circles because we want to learn a little bit more about them, especially when we're dealing with perimeter, because it's not as straightforward as some of our other shapes. So when we're looking at circles, specifically the distance around circles, we're going to look to see if we can find a relationship. So if you go to this link here, that will take you to a web page that looks something like this. And basically what we're going to do is we're going to look at different circles. We're going to look at the circumference, which is what we call the distance around a circle. So the circumference is basically the perimeter of a circle. And we're going to look at the relationship between the circumference, or the distance around, and the diameter, so the distance across, from one side straight through the center to the other side. So in this case, the diameter is 4. So we want to look at what is the relationship between the diameter and the circumference. And we're going to make different shapes. So we can look at 6 and see the relationship between the two. 8. Maybe look at 10. 12. Maybe we go even smaller. 2. Look at 1. Oh, we do see a relationship there, because our circumference is now changed from an actual number to just a symbol. So by looking at all of these different relationships between the diameter and the circumference, what we should find is that the circumference, or the distance around, is just the diameter multiplied by a special number, which gives us their circumference. And if we go back all the way down to 1, if we can get it nicely there, doesn't want to. There we go. So we can see that when the diameter is 1, the circumference is pi, or 3.14. So that is the relationship that we were looking for. So when dealing with the circumference, the formula for the circumference, again, we could use perimeter because that is another word for it. But generally speaking, when we use the word circumference, we are talking about the perimeter. So the formula for the circumference of a circle is C equals pi times D. And this basically works out to circumference is approximately equal to 3.14 multiplied by the diameter. Now you should have a pi button somewhere on your calculator. You may have to use a second function button, or it may be a button on its own. So you can use either 3.14 or the actual pi button. You might get a few differences in terms of your actual answer, but it would be in terms of like decimal places usually. So usually when you round, you'll get the same answer regardless of which one you use. Moving on, just to get our brains kind of working a little bit, we are going to look at some scenarios where, again, when we're dealing with composite shapes, we may not have the normal shapes that we're used to. So we may not have full circles. So we may have to adjust our formula slightly to get different representations, depending, again, on what our shape looks like. So right here, we want to draw the portion of the circumference represented by the formula. So in our formula here, C equals 1/2 times pi times diameter, I want to draw on this circle, or highlight, whatever you'd like to call it, the portion of the circumference that I'm representing. And what we're going to do, depending on how you do it, you may do it a different way. you should be getting roughly, or you should be connecting that half of our circumference is represented by this formula. And again, because of this part right here, that half, that is representing or telling us that we need, or we're calculating half of our circumference. If we look at another example, here we have circumference equals 2/3 times pi times diameter. So I need to represent or draw, what does 2/3 of the circumference look like? Well, it's nice that our circle is divided up into groups of 6 that you could say. So 2/3 is the same as saying 4/6. So I'm going to draw around 4 edges, or 4 portions, you could say. So again, this formula, or this line, is represented by this formula because of this fraction here, which means 2/3 of our circumference is what we're calculating. So again, depending on what composite shape we get, we may have different, we may have to adjust, our circumference formula just slightly, again, depending on what we have. So what we're going to do here in our example is we want to calculate the perimeter of this composite shape. So first, what we want to do is we want to use a highlighter to show the perimeter of the shape, composed of a semicircle, which just basically means a half circle, a rectangle, and a right angled triangle. So that's what we want to do first. We want to figure out, okay, what is our perimeter first? And remember, perimeter is the distance around the object. So in this case, our object, here we'll use an actual highlighter, our object is this composite shape, or all these shapes added together. So if I want to find the distance around the shape, I need to make sure that I'm staying by going around, and I'm not going through the middle. Because again, the distance around the object is what we have here. So that's the distance around the object. Now you may have, by mistake, maybe you thought, okay, well, I see a line here, so I'm going to highlight that. I'm going to highlight this portion down here as well. We have to keep in mind that's not around the object, that's inside the object. When we're dealing with the perimeter of a shape, we want to figure out the distance around the object. Now, you may get some questions that may ask something like, what is the amount of fencing required, or things like that, where if these lines represented fencing, then yes, you would have to add them up. But if we're talking about the general perimeter, that's the distance around. So we're not including anything on the inside. The inside is there just to help us understand what shapes we're dealing with, as well as give us an idea of what some of the measurements are. So just be careful when you're dealing with perimeter. With area, it didn't matter because we were looking for the total space that it took up. So we use those lines again to help us determine those basic shapes. So what we need to do now, after we've highlighted and figured out what sides we need to add up for perimeter, we need to find the missing lengths of on the figure and label them. So we have 11 at the top, we have 4 down here, so we're missing this shape over here, or this portion, I'll do in red. So we're missing that portion, we're missing this portion down here in green, we're missing this little portion here in blue, and we're missing this portion here in purple. So those are the missing lengths that we need to determine. Some easy ones to figure out. Well, this green one is 11, because we have a rectangle here. So we know that this side is 11 centimeters. Another easy one is this blue part. And the blue part is easy because we know the total distance across, or the total width, you could say, of the rectangle is 6 centimeters. We can see that 4 centimeters is this lower part, or this part of the right angle triangle. Because of these two lines, we know that these two sides are the same. So this missing part here has to be our total distance, 6 centimeters, minus what's already taken up or already used, which is the 4 centimeters. So that means this little portion here is 2 centimeters. So that only leaves us with two parts now to figure out: this diagonal line and this curved semicircle. We're going to start with the semicircle because that's just what we kind of talked about. So with the semicircle, because I'm looking for half of it, or the circumference or the perimeter, or the distance around, I need to use my circumference formula. And again, our circumference formula is C equals pi times diameter. But because I'm dealing with half of a circle and not a full circle, I'm also going to multiply this by half, because I want half of the original circumference. So in this case, I have pi, or 3.14, times the diameter, which is 6, this distance across here, and then times a half, or times 0.5, or you could say 3.14 times 6 and then divided by 2. And in the end, we should get a circumference of our semicircle of 9.42 centimeters. So that distance across is 9.42 centimeters. And now that only leaves us with finding the distance, or the length, of this diagonal. This is going to take us back a lesson, because when we're dealing with a right angle triangle, hopefully we remember that we can figure out the length of the longest side, or the length of any side really, if we're given at least two others, by using the Pythagorean theorem. Because we're looking for the longest side, side C in our formula, or the hypotenuse, we're using the formula a squared plus b squared equals c squared. In this case, it doesn't really matter what a and b are, because they're both the legs and they're both the same. Oops. So 4 squared plus 4 squared equals c squared. So we get 16 plus 16 equals c squared, or 32. Equals c squared. And again, remember, the last step that we have to do when finding the Pythagorean theorem, or finding a side length, is we have to square root our answer. So the square root of 32 gives us we'll round it to 5.66 centimeters, equals c, or this distance here, so 5.66. So now that we have all of our measurements, or all of the measurements for the sides around, or the distances around, or the lengths around, however you want to call it, we can actually calculate the perimeter now by adding them all up. Because again, the perimeter is just the distance around, so I'm just going to add up all of my sides. So the perimeter is going to equal side 1 plus side 2. Actually, let's color code this so we know what we're dealing with. So side 1 is the one that we're given. So in black, the 11 there, plus side 2 in red, plus side 3 in green, plus side 4 given to us in black, plus side 5, the diagonal in purple, and finally plus side 6, which is that little blue part that we figured out. Now, again, you may not have to write this out, but I'm just trying to show you where we are getting this formula from. Oops. So we add up all our sides. So we have 11 centimeters plus 9.42 plus 11 plus 4 plus 5.66 plus 2, and we add all those up to get our final perimeter. And when you add all these up, you should get roughly 43.08. It does want us to round to 1 decimal place. So this becomes 43.1 centimeters because we want to round it to 1 decimal place so that we look after, or the position after. So because it's 8, that's higher, that's 5 or higher, so we're moving that 0 up to a 1. So 43.1 centimeters is the perimeter of our composite figure that we can see here. So that distance around. What we're going to do next, because again, many different examples that you might get when you're dealing with composite shapes. So again, you have to make sure that you are recognizing what those basic shapes are, and then just determining the perimeter or the lengths of each segment. We're going to look at 4 examples of the shapes that we looked at, or the same question we just looked at, and see if you can determine where the individual went wrong in their calculation. So it's going to be the same thing that we just did. So here is example 1. You can take a second, you can pause the video to see where did this individual go wrong. Or did they go wrong and maybe we made a mistake? I'm going to move on to number 2. Where did this individual go wrong, or are there anything that they can improve on in what they've done? Again, you can pause the video to take a second to look at it. Moving on to number 3. Again, taking a look at this, where did this individual go wrong, if they did, or is there anything they can improve on? And then moving on to the 4th one. Again, where did this individual go wrong? And if they didn't, or they got the correct answer, what can they improve on? So I'm going to go back up to the first one. Again, if you needed to go back and just take a look at each one, you can do that and pause to take a longer look at them. But in example 1, where did this individual go wrong? We see that they've calculated the circumference correctly. They've found the B length, or that diagonal. They've taken half of the circumference, which is correct, but they got a different answer from us. So how did they get this answer? And you could look at the perimeter. But I think we can see, or hopefully, if you didn't, you can see that what they've done is they've gone through and they've highlighted every line in our shape. So they highlighted too many sides. Right? Again, the perimeter is the distance around. So we just want to be careful that when we're dealing with the perimeter, we're finding the distance around the object, not through and in between the object. So we just want to be careful of that. So that's where they went wrong in this example. So if we actually took out the 2 6's here and just replaced the 1, so the 2, we should be correct. Or actually, they have the 11, they have the 2, 5.7, so they actually included that. So we just need to take the 2 6's out. They double counted 6 for some reason, and then that should give us a more correct answer. If we look at example 2, they did get the same answer as us. We are missing a couple things that would make this an excellent question or an excellent response. So we are missing our units. We just want to again be sure, especially when it says include the units, we want to make sure that we have them there, especially when you've already gone through or they've already gone through and included them in each spot. The other thing is we're missing all of the work here. So because we're missing all of that work, if there was an issue or if something went wrong, we would not be able to give them part marks, or we don't know where or how they got some of these answers. So you always want to be sure, especially for ones where you're actually using formulas. So say, for example, finding this measurement here, the diagonal using Pythagorean theorem. This measurement here, finding the circumference of a semicircle. Those are ones that you would probably want to show work for because it's a little bit more detailed rather than, say, this section here where you're just subtracting two numbers, or even this section here where there's not really a calculation, it's more just mathematical reasoning. So if there's anything where you have to use a formula to solve, I would definitely recommend making sure that you do include that information. Otherwise, it is a very solid answer because it is correct. In question 3, or in solution 3, I think, again, we have the correct answer for our final perimeter. They've highlighted everything correctly. They've gone through and they've shown in detail what they've done with each, or how they calculate each single part. They've labeled it section 1 or length 1, 2, 3, and 4. And they've done everything else. So again, I would say this would be a perfect solution. It's very detailed, answers the questions, and everything is clear and neat. And finally, moving on to solution number 4. So again, looking through this, they highlighted everything, the correct parts. They went through and they made the calculations to figure out the 1 measurement for length 3. For length 2, there is a little bit of a confusion there. So they are using the idea that, well, if it's an isosceles triangle because two sides are the same, then the other side is just double that. So they did some incorrect calculations here. So here they would need to use Pythagorean theorem, or sum of squares, which is the a squared plus b squared equals c squared, to figure out that missing length. The other slight mistake that they did, they have the right formula for our semicircle for circumference. However, they need to divide by 2. They need to divide by 2 because it's a semicircle, or it's a half circle. So again, this individual just needed to make that small adjustment, understanding that we're dealing with a half circle and not a full circle. And then again, otherwise, they have the right steps. They're adding up the correct sides. Just some slight calculations errors in determining 2 of the lengths. But again, hopefully this gives you an idea, at least to see of what you might need to include, some things to watch out for, some common mistakes when dealing with composite figures, and especially when dealing with circles and semicircles and so on. So again, many different types of questions or examples that we could come up with when dealing with composite shapes. Again, when dealing with perimeter, remember it's the distance around the object, not through the object. So distance around the object, and just make sure if you're dealing with half shapes that you are accounting for that when determining either the length or the circumference, depending on what shapes you're given. And again, for circumference, we know that is pi times diameter. So again, just take your time and just be aware of what shapes you're actually dealing with when dealing with a composite figure.